All right, Algebra 2, let's get into Lesson 31, Systems of Equations. I know we've done systems of equations for a few days now. Last lesson was linear systems with 3 variables. Now we're going to talk about parabolas and circles and etc. and how systems of equations interact and how you can find solutions. So let's get into it. Going to be a ton of graphing in this lesson, and I'll send you home with a bunch of graph paper to help you out. So this one first says, sketch the lines given by x plus y equals 6 and negative 3x plus y equals 2 on the same set of axes to solve the system graphically. Then solve the system of equations algebraically to verify your graphical solutions. To graph these, you can set up t-tables. You know, x and y, plug in x and get y. Gosh, for the first one, if we plugged in 1 for x, we would get 5 for y, 2 for x, 4, negative 1 for x, 7, etc. Or what I usually do is put it into slope-intercept form, graph the y-intercept, and then use the slope. Negative 1, positive 1, to graph a few points and then draw a line. This one would be y equals 3x plus 2. So you go to 2 and then up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And you can actually find where the lines meet that way. So it looks like we're at 1, 2, 5, 10, 11, 12. 212 would be a solution to those 2 lines, to that system of equations. But it does want us to solve the equations algebraically. I just set them both equal to y, so let's go ahead and use that and solve for x. So 4 equals 4x. Ooh, x equals 1. What did I do? No. Oh, I didn't look at how the axis is labeled at all. That's hilarious. That would be an amateur move. Looks like we went over 1, up 6. Let's see if we can find 6 for y. Nope, it's 5. So 2, 4, 1, 2, 3, 4, 5. It's really good to see how your x and y axis, how they've done the numbers or how you've done the numbers. Goodness. Let's go ahead and solve for y. Negative 1 plus 6, y equals 5. So we get the same answer, algebraically and graphically. So you can see the graph. Suppose the second line is replaced by the line with the equation y equals negative x plus 2. Plot the 2 lines on the same set of axes and solve the pair of equations algebraically to verify your graphical solution. This was the first one we did from the previous slide, and then the new one. If I go to 2 and then a slope of negative 1, and if you look, this one was y equals negative x plus 6. Y equals negative x plus 2. My slopes are equal, so the lines are parallel, so there's no solution. But let's show you that algebraically. So negative x plus 2 equals negative x plus 6. I'm going to add x to both sides, and my x's cancel out, and 2 does not, in fact, equal 6. So I have no solution. Then lastly, suppose the second line is replaced by the line with the equation 2x equals 12 minus 2y. Let's rearrange that. I'm going to move the y over here and the x to the right. Divide everything by 2. And I have the same equation from the first part of this example. So even yeah. I mean, if I set those equal to each other, which is sort of, humorous, negative x plus 6 equals negative x plus 6, add x to both sides, and I've got 6 equals 6. Solution is all real numbers. You have the same line. They're equal. We could actually say that the solution is all points x, negative x plus 6 are solutions to the system. Okay? I've never seen a solution answered this way, so it's pretty exciting, pretty interesting to see the solution written that way. We've seen that a pair of lines can intersect in 1, 0, or an infinite number of points. Are there any other possibilities? The 3 previous problems we saw, the first one we saw 1, then we saw that was where 2 lines just intersect. Then we saw 0, which is parallel lines. And then we saw an infinite number of points, which is the same line on top of each other. There are no other possibilities. 1, 0, or infinite number of points is the only answer for 2 lines. As we get into other shapes, we'll see other answers, but for a pair of lines, we only have 1, 0, or infinite number of possibilities. So let's look at this exploratory challenge. Suppose that instead of equations for a pair of lines, you were given an equation for a circle and an equation for a line. What possibilities are there for the 2 figures to intersect? Sketch a graph for each possibility. I sketched graphs for us. Here we have 0 solutions. Because the graphs don't intersect at all. So there's no solution to their intersection. Here we have 1 solution. Okay, the line, so we have 1 solution. The line is a tangent to the circle. And here we have 2 solutions. And those are our only possibilities for a circle and a line intersecting. Graph the parabola with equation y equals x squared, which I've done for us. What possibilities are there for a line to intersect with a parabola? Sketch each possibility. Again, here we have 0 solutions. When the line and the parabola don't touch. Here we have 2 solutions. They intersect in 2 points. And here we have 1 solution. And those are really our only possibilities. Sketch the circle given by x squared plus y squared equals 1, and the line given by y equals 2x plus 2 on the same set of axes. 1 solution to the pair of equations easily identifiable from the sketch. What is it? First of all, let's talk about this circle. Circles, you get x minus h, quantity squared, x minus k, quantity squared, equals the radius squared. So h and k is the center. Let's erase that and write it better. It's the center of the circle, and r is the radius of the circle. So if we look at this problem, my center is, 0, 0, and my radius is the square root of 1, which is 1. So that's what we've shown here. That's 1 and negative 1, 1 and negative 1. And it looks like I cross here and there. I can easily read one of them. I'm at -1, 0 is one solution. Because it was easy to read. It crosses at a grid, at where the grid intersects. So it was perfect to read. But we need to be able to easily sketch some circles, and most of them will be set up like this for us, where we can just figure out the center and the radius and sketch away. As an aside, this point here, which is not easy to read, we would have to solve algebraically. That's why graphing isn't always the best way to solve a system of equations. Substitute y equals 2x plus 2 into the equation and solve the resulting equation for x. So I'm going to work on this equation, and you guys can work on it too. I'll be right back. So this is where I am so far. I'm going to go ahead and use the quadratic formula to find my solutions, and I will be right back. So I got -1 and -3/5. What does your answer to part D tell you about the intersection of the circle and the line from part C? There are two intersections of the line and the circle. So when x equals -1, then y equals 0. As the sketch shows, that's what we found. So -1 comma 0 was in fact a solution. When x equals -3/5, that's a -3/5. Then plug that in, you would get y equals 2 times -3/5 plus 2 equals 4/5. So -3/5, positive 4/5 is the other solution. And we solved it. Okay? So I just want to point out very briefly, we had a circle with radius of 1 and a line that came through it. That's an awful. Okay, when we're trying to find the solution to the systems of equations, we're looking for where the circle and the line meet. So here we would have two solutions, not representative of our actual solution, and it looks a little bit like Mickey Mouse, but we're looking for both solutions. So when you graph it, you can see how many solutions you would get. And another important thing, I've been using Desmos, which is an app you can download onto your computer to graph. The graphing calculator is a little bit harder to do circles, but this one is pretty awesome, and I'll show you how that works if you'd like me to. All right, let's do some exercises. So draw a graph of the circle with equation x squared plus y squared equals 9. Our center is 0, 0, and our radius is 3, which is represented right here, 0, 0. And if we go over 3, up 3, over 3, and down 3, you can draw your circle pretty easily. What are the solutions to the system of circle and a line when the circle is given by x squared plus y squared equals 9 and the line is given by y equals 2? Let's see, the solution is right where they cross. And if you eyeball it, it looks like I'm over at 1, 2, x is 2.5, y is 2, and then x would be -2.5, y is 2. So graphically, that's what it looks like our answer is going to be. But if we go ahead and try to solve it algebraically, we're going to put y equals 2 into our equation. X squared plus 4 equals 9. X squared equals 5. x equals plus or minus the square root of 5. I don't have that one memorized, I apologize. I know it's 2 point something, 2.23. So x equals plus or minus 2.23. And you'll see I am not correct. I am off by a few tenths. So algebraically is always going to give you a more accurate answer. But at least this sort of taught us where to sort of head, where to look, where to focus in. What happens when the line is given by y equals 3? It looks like we're going to have one solution, right? Let's go ahead and try it. X squared plus 9 squared equals 9. Oops, I already did it. 3 squared is 9, so x squared equals 0, so x equals 0. So our answer is 0, 3. And only one solution, which is shown by the graph. What about when x equals 4? It looks like we're going to have no solution. X squared plus 16 equals 9. X squared equals negative 7, square root of both sides. I don't have a real answer. I square roots of 7. So no real solutions. Okay, by solving the equations as a system, find the points common to the line with equation x minus y equals 6 and the circle x squared plus y squared equals 26. Graph the line in the circle to show those points. So I did that using Desmos. Looks like I have two solutions. So let's go ahead and try to solve it. I'm going to solve this one for x and plug it in. Okay, I'm going to push pause and work on the algebra. At this point, I like to point out the awesomeness that I chose to substitute x into the equation, so I'm trying to solve for y. So I used the quadratic formula, and I used the quadratic formula and got my answers and went over here and went, whoa, wait a minute, x can't be negative 1 or negative 5. And then I remembered I was solving for y. I can use the quadratic formula to solve for y. I just need to remember that I'm doing that. So let's go ahead and find our x's. So if y equals negative 1, I'm going to use x equals y plus 6 because it's easier. So if y equals negative 1, x equals 5. So 5 comma negative 1. And if y equals negative 5, x equals 1. So I have my two answers, which is represented on the graph. Okay, number 3, graph the line given by 5x plus 6y equals 12. And the circle given by x squared plus y squared equals 1. Find all solutions to the system of equations. I don't think this graph is right. I'm looking at it right now. Let's look at it. So right here we have a circle with center 0, 0 and a radius of 1, which looks right. And this one right here, let's put it in slope-intercept form. 6y equals negative 5x plus 12. Y equals negative 5 over 6x plus 2. Well, that could be 2. Let's see if our slope is right. So we went, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Nope. It's completely off. It should be in that direction. Oh, and it should be positive 2. I'm not even looking at the right part of the graph. So my graph should be up here. Still not crossing. So if we were up at 2, we'd be down 5 over 6. Okay, down 5 over 6. It would be a line that looks similar to that, maybe not so scribbly. So down 5 over 6, down 5 over 6. Not sure what that little graph is. Okay, but basically we have no solution. The line and the circle don't intersect, so there's nothing to solve. Number 4, graph the line given by 3x plus 4y equals 25 and the circle given by x squared plus y squared equals 25. So we're at 0, 0 with a radius of 5. Find all solutions to the system of equation. Verify your result both algebraically and graphically. Okay, so let's go ahead and solve this equation for, it doesn't matter, they're both going to be messy. Let's just do y. Negative 3x plus 25, negative 3/4 x plus 25/4. Yuck. Okay, let's go. X squared plus squared. I'm going to push pause and work through this. Well, that was fun. Let's talk through it. So we got to this part, and then I said I'll work on it, and that's what I did. So if you look here, I plugged in y for y in the circle equation, went through the math, got everything set equal to 0, and then I plugged it into the quadratic formula. I ran out of space to actually write down plugging into the quadratic formula, so I used my calculator. And underneath the radical, luckily, everything canceled out, so I got square root of 0. Then I just took 75 over 8 divided by 2 times 25 over 16 and got 3. Plugged it into the first equation and got 4. So our solution up here is 3, 4. Graph the line given by 2x plus y equals 1. And the circle given by x squared plus y squared equals 10. Find all solutions to the system of equations. Verify your result graphically and algebraically. So it looks like we have 2 solutions, so we should be able to find them. It also looks like, well, this one might be negative 1, 1, 2, 3. Negative 1, 3, you cannot read that. Negative 1, 3, and the other one I'm not sure what it is, but let's go ahead and solve it. Let's substitute y for the circle equation. So this is a circle at 0, 0 with a radius of a square root of 10, which is sort of stinky, but that's all right. Okay, I'm going to work on this. I'm going to push pause. Okay, quadratic formula. Under here, I got the square root, which gave me 14, so 4 plus or minus 14 over 10. 9/5 was one of the x's, and negative 1 was the other. If I plug them into the line equation, which was easier, I get negative 1, 3, and 9/5, negative 13/5. Okay, last one. Go ahead and try this one on your own, and we can check solutions, but you don't need me. I've got 2 equations. Go ahead and find the solutions. There will be 2. I have a parabola and a line. So there we go. Check out the solution. I got 1, negative 3, which is right there. Oh, sorry. Is right there, over 1, down 3. And then I got negative 2, 0. Cool. Nice work today.